Hello, and welcome to Astronomy Toronto. My name is Randy Attwood. This is the first show of 3 on topics, current topics of general interest in astronomy and also the activities of amateur and professional astronomers in the Toronto area. We'll be looking at astronomy in Canada. We'll get some views in later shows of Voyager pictures of Saturn, and we'll also be looking at recent expeditions taken by members of the Toronto Centre of the Royal Astronomical Society of Canada to view total eclipses of the sun. Today, though, we're going to be talking about Canadian astronomy. And with me, my guest is Ian McGregor from the McLaughlin Planetarium. Thanks, Ian, for coming by today.
Very glad to, Randy.
Ian is a producer at the McLaughlin Planetarium, and his job is mainly to educate people in about astronomy and the latest discoveries that astronomers are making. What different types of astronomy, Canadian astronomy, are there, Ian?
There's several different areas, Randy, that we can look at Canadian astronomy. We can look at Canadian astronomy from perhaps first a professional viewpoint, what professional astronomers do, large telescopes, observatories, what research is going on done by Canadians about trying to understand our universe. We can also look at astronomy from the viewpoint of education, what is going on to try and show to Canadians what actually is happening in astronomy, what our universe is like. And perhaps another area we might consider as well might be amateur astronomy. Anybody can be an amateur astronomer and perhaps enjoy some of the wonders of the skies overhead.
Maybe first we'll talk about what the professional astronomer is up to. I hear that Canada has many large telescopes, and especially the newest telescope that Canada helped build in Hawaii.
Canada's newest and largest telescope is located in the middle of the Pacific Ocean on the island of Hawaii, in the Hawaiian island chain. It's a very large instrument, actually the 6th largest telescope in the world, and it's known as the CanadaFrance Hawaii telescope. It is it's called this because it's been built by the Canadian government, the French government, and the assistance of the University of Hawaii. Now, this telescope was officially opened in September of 1979. It is a major research tool which astronomers can use. I mean, we might perhaps ask ourselves, well, why do Canadians leave Canada in order to do astronomy? Well, we've got a large country and lots of places. Why do we leave the country in order to observe? Well, it turns out that the site that has been chosen for the CanadaFrance Hawaii telescope is on the top of a very high mountain. Actually, it's an extinct volcano.
Hopefully.
Hopefully it's extinct. And at this site, we have a number of very good advantages as far as observing our universe. First of all, we are very high. We are above a large portion of the Earth's atmosphere. Cloud level is below the top of the mountain in which the observatory is located.
So you get a lot of clear sky.
Got a lot of clear sky, a lot of dark sky. This is what we want.
Well, we have some pictures that you've brought with you today of the telescopes. Maybe we can look at those now. Here's an outside view, and you can see the dome.
Okay, here's a photograph of the dome of the CanadaFrance Hawaii telescope. This dome is 32 meters in diameter, and it rises to a height of about 11 stories. The telescope itself is inside this dome, and as we can see in this picture, we've got a lot of blue sky behind the telescope. It reminds us that we're up very, very high. We have no vegetation at this height because we're up so high.
Well, 4,200 meters, did you say?
About 4,200 meters.
There you can see it high above the clouds.
And here we can see it well above the clouds. Any lights that might come from cities or towns on the lower levels of the island are completely covered by the clouds or blocked out. This telescope the site has 2 different advantages to it. The air around the site is about 10 times drier than at sea level, and this improves the detection of infrared radiation. And this is one of the major areas that this telescope is being used. This is showing an interior of the dome and the telescope itself. The telescope itself has a mass of 325 tons. Of this, the mirror itself, the actual light collector, has a mass of 14 tons. The design of the telescope is similar to the famous Mount Palomar telescope with a Palomar-type horseshoe mount. And in this picture, we can perhaps just pick out a dark-colored horseshoe in there, 10 meters in diameter, and this enables the telescope to rotate around the polar axis, and so that the telescope can see all areas of the sky. This is a diagram showing the telescope. There are several parts to a large telescope like this. At the bottom of our picture, we have where the mirror is located for it. The mirror is 3.6 meters in diameter. Again, one of the largest mirrors in the world. The mirror collects visible light. And in this particular picture, we have the light coming down. It goes back up the tube to a collector, and from there you have various instruments used by astronomers to analyze the light, whether it's coming from galaxies or star clusters or nebula or whatever object we happen to be observing.
To be so heavy, the mechanics and the motors to drive the telescope must be incredibly precise.
Oh, incredibly precise. I believe that there's an alignment to within like a millionth of a centimeter or something like that
Right.
is done in the alignment of it.
I see. And so it rotates to follow the stars, is that right?
It rotates to follow the stars. The Earth, during the course of the day, is gradually rotating, and this means that we can be following and tracking these various objects. Here we see the telescope itself. We have the sort of yellow-orange colored horseshoe, which is actually holding the tube. The mirror is at the bottom of this picture, and at the top is the focus, where we perhaps put various bits of equipment in order to study the light that's being collected by the telescope itself. The CanadaFrance Hawaii telescope is the 6th largest telescope in the world. The largest telescope in the world is owned by the Soviet Union. The next largest is the very famous Hale telescope on Mount Palomar. Then we have other countries that have telescopes, but the CanadaFrance Hawaii is the 6th largest, and Canadian astronomers have a lot of time on this particular instrument.
On the right-hand side, then, you can see the comparable sizes in mirror diameters. At the top, the Russians having the largest, and then they're getting smaller and smaller, also much, much less expensive.
This is something which is originally was thought quite a while back that we would not be able to get big telescopes constructed, but it seems that new technology is enabling us to find out things about the sky and our ability to make large telescopes to study them.
Not only to make a large mirror, it's very difficult, but also the fact of the gravity stretching and pulling it down the telescope begins to warp it. And that
this is a big problem with telescopes. So once the mirror gets very, very large, there starts to be sag in the middle of it. This is a picture, the first picture taken with the CanadaFrance Hawaii telescope, and it's showing a globular star cluster, which is a family of about 500,000 stars, one of about 200 smaller satellites of our Milky Way galaxy.
the stars are black, of course, because it's a negative.
It's a negative picture. Astronomers like to use a negative picture when they're observing the sky.
So how much of this telescope does Canada own?
Well, the telescope was made with the help of the French government and the University of Hawaii. Basically, Canada and France are paying for it. The costs of it, 42.5% are being borne by the Canadian government, 42.5% by the government of France, and the remaining 15% is by the University of Hawaii. Basically, the University of Hawaii is providing the site, plus certain backup facilities that are necessary for astronomers when they travel to Hawaii.
So would Canadian astronomers be able to use it 42% of the time?
That's correct, and that gives us a very powerful instrument that Canadian astronomers can use.
What about telescopes in Canada itself?
Canada has several telescopes that are in Canada itself. The most well-known of these is probably our next picture, which is the David Dunlop Observatory.
Mm-hmm.
The David Dunlop Observatory is the largest telescope in Canada. It has a mirror which is 74 inches in diameter, and here we see a picture of the observatory building itself. The shutters are open so that the telescope, if it was being used, could actually look out and look up into the sky. Of course, it's used at night.
Right.
The David Dunlop Observatory was opened in 1935. It is a gift from Mrs. David Dunlop in memory of her husband. The telescope is used as a primary research tool. It's located in Richmond Hill, about 15 kilometers north of downtown Toronto. There's some problems with the lights, and that's what we might expect from any large.
Well, when it was built 40 years ago.
At that time it was countryside, but now I'm afraid it's built up since that period of time. The observatory has public hours as well. It's not only used for research, but it's possible in the period from roughly April to October to go up and visit the observatory on a Saturday night. If the sky happens to be clear, then you can actually look at whatever object happens to be on view that particular night.
You just phone up and make reservations. Maybe we should stress that.
That's right. You get to phone up, make a reservation. There's a limited number of people that are allowed on a given Saturday night, but it's a good opportunity to see a large Canadian telescope.
Because it's so bright up in Richmond Hill, they've decided to build another telescope down in Chile, isn't that right?
The David Dunlop Observatory is operated by the University of Toronto. The University of Toronto has a large telescope located in the southern hemisphere in Chile. And this particular telescope has a 24-inch mirror, and it's used for observing the southern hemisphere. We must mention that the northern hemisphere skies are different than the southern hemisphere skies, and building an observatory down there gives us another window on another part of the sky.
Here's another observatory used by Canadian astronomers. This is in London, Ontario, owned by the University of Western Ontario. It's the Elginfield Observatory.
This is the third largest telescope that we actually have in Canada. This is, has a telescope in there, 48 inches, 48-inch mirror. Just opened a few years ago, and there's a lot of research that goes on at this particular observatory. Canada does have other observatories as well. Very recently there was an observatory opened in Quebec known as the Mount Megantic Observatory. It has a telescope with a mirror 64 inches in diameter, and it's a new powerful observing tool. This Mount Megantic is located roughly between Montreal and Quebec City on the Canadian-US border. There's also another observatory out in Western Canada, the Dominion Astrophysical Observatory, located in British Columbia, and it has a 72-inch mirror.
Why do they have all the different types of mirrors? Wouldn't it be easier just to make the largest they can and have that?
Oh, it'd be nice if they could go ahead and do that and just build maybe one standard design and just make it a big telescope. But I guess the cost gets in there. Big telescopes cost a fair amount of money, and they usually often intend to be different designs. Now the 74-inch at the David Dunlop Observatory and the 72-inch in British Columbia are the two largest in Canada itself. We don't know if there's going to be another large one built in Canada. It seems the best place for big telescopes is out of the country, in high mountains.
It's been difficult through the years to make large mirrors. I think the large mirrors are made of glass, and they take years and years to cool after they're made. But they've reached a point now where they can't make a perfect large mirror. So now they're taking smaller mirrors and putting them together, and they've already built a telescope like that. You know,
it is possible now actually to cool the mirrors fairly quickly, so that you can kind of produce them against the cost. A new project that has just started in the observatory just opened just recently is the multiple mirror telescope on Mount Hopkins in the United States, and this is a telescope that actually has 6 mirrors that are aligned using lasers and computers, and it has, I think it ends up, I can't remember now the size of the mirrors, but I think it gives you something like effectively about 150-inch instrument, something about the same size as our CanadaFrance Hawaii telescope.
You mentioned infrared light. They want to study infrared light from the CFHT telescope. They also are interested in ultraviolet light, aren't they? Different wavelengths tell them different.
There's many different wavelengths we can observe. Telescopes in the past have only been observing really visible light, and it's possible to examine other parts of the spectrum now. We can observe X-rays and ultraviolet and infrared and radio waves and optical wavelengths, and for each one of these wavelengths of energy we get some kind of a different telescope in order to study that particular area of the sky.
One thing that's interesting is a lot of this light doesn't reach us. It's blocked out by our atmosphere, so that the next step is putting a telescope up into Earth orbit, up above all the atmosphere.
This is the next plan that's being worked on, the space shuttle, which is going to be a kind of a transport vehicle for taking things up into space. And one of the missions that's going to be taking place in the future is to put a space telescope up in Earth orbit. This means to be well above the Earth's atmosphere, much higher, of course, than Mauna Kea and everything like that. And this will give us an excellent observing platform. We don't have any atmospheric effects that we'll have to worry about.
All right, so there's an entirely different spectrum of radio waves, which they're interested in. It's a totally different design of telescope, radio telescopes.
Radio telescopes look very different than optical telescopes. Optical telescopes use a mirror in order to collect the light. With radio telescopes, we talk about a dish. And in Canada, the largest dish that we have is the Algonquin Radio Observatory, which is located in Algonquin Provincial Park in northern Ontario. The Algonquin Radio Observatory has a dish 150 feet in diameter, and here we can see a picture of it. This dish acts as a receiver of radio radiation from space. The energy falls onto the dish. It is reflected back up into the receiver up in the upper right, and then astronomers can actually observe the radio waves that are coming in and study the structure of the Milky Way galaxy, the structure of quasars, these strange objects apparently on the edge of the observable universe. And it provides a very powerful observing tool for looking at our universe in a different way.
I noticed in the picture there, it wasn't covered by anything. It's out in the uncovered and.
That's right. If we had an optical telescope, you had to be inside a dome, and mirrored, had to be covered and protected. But a radio telescope can operate pretty well anytime. You can operate during the daytime. You can operate at nighttime. The only real requirement is that whatever object you're going to be observing happens to be at the sky at the time you're going to observe.
So you don't look through a telescope, but what do you see, the information coming from it?
We look through an optical telescope, we could actually see the particular star cluster or nebula that we're looking at. In a radio telescope, what we're getting is signals that might appear, say, on a chart recorder, or information that would go into a computer and be analyzed. And we sort of set up a map of that particular part of the sky, which gives us the intensity of the radio radiation coming from that part of the sky.
So you mean what you get is like a weather map with, instead of isobars, you get different regions of radio intensity, and it might be around a galaxy, and you can see that.
And we find some more structure, and the galaxy might look very ordinary through a telescope, but as soon as we use a radio telescope, all of a sudden we start to discover amazing things about it.
Have they ever picked up any alien transmissions with these, like some AM radio from Mars or something?
Not yet, although astronomers have set several projects over the past couple of years to try and pick up radio signals from maybe planets that might be orbiting other stars near us in space. And then if there happened to be intelligent life or something like that that would be broadcasting, we could pick up their signals. The Earth itself, of course, is broadcasting into space. The radio radiation that's produced by radio stations and television and such broadcasts out into space. And if we were alien beings not that really far away from us in space, we might be able to pick up the Earth and or listen to Donald Duck cartoons, or
I Love Lucy.
I Love Lucy, or the latest bit of knowledge coming from the Earth.
Is the Algonquin radio telescope the only one Canada owns?
Canada has another large observatory, radio telescope, located in British Columbia again, Penticton, BC. This is the Dominion Radio Astrophysical Observatory. The Algonquin Observatory has a dish 150 feet in diameter. The Dominion Radio Astrophysical Observatory has an 84-foot dish.
Now, there are efforts underway to do something which has never been tried before, a pioneering effort by Canadians with several, more than one at least, radio telescope. Could you tell us about that?
Canadians are pioneers in using radio telescopes as in kind of a long baseline arrangement. Back in the 1960s, it was thought that you could perhaps combine the signals from two radio telescopes, two dishes. They might observe the same object, the same period of time. They might be hundreds, thousands of kilometers apart. The signals will be brought together, and then by using a computer, you could perhaps match the two signals, and then instead of using just say a dish that's 150 feet in diameter, you might come along and use a long baseline, for example, one stretching maybe from North America perhaps to Europe. The only place you can use a long baseline type of design is if you have a country that has a great east-west extent. Canada is an example, the United States is an example, the Soviet Union, China. These are about the only countries that can really do a good long baseline type of work. Canadian astronomers are also thinking about a new kind of project along that lines, known as the Very Long Baseline Array. And the proposal is that we would build 8 dishes, as we call them, 8 radio telescopes. The diameters of the dishes would be somewhere between 25 and 30 meters, and these would be located across Canada. The proposal that's before the National Research Council in Ottawa right now is for 1 dish in British Columbia, another in Newfoundland, 1 in Quebec, 1 in Ontario, and 4 in the Prairie provinces.
So what you're saying is if you have several, then it's in effect as if you have a radio telescope the size of Canada.
Exactly.
So as if you're 2 people standing on different sides of the room, if they're looking at the same object, they see different perspectives and you learn more about the object. So with these telescopes, if they're all looking at the same object at once, all the information will be fed into computers and they'll have better resolution, as they say, to see things clearer.
Much more clearly. You'll be able to really study the detailed structure of galaxies, or probably probe very deeply into quasars, these objects that we've known about for about 19 years and still really don't quite know what they are. But with this kind of an arrangement, we could really be able to study these things in the sky.
Ian, you're interested in communicating all this to the public. Maybe you could tell us a bit about your job and a bit about the planetarium.
Well, the McLaughlin Planetarium is one of several planetariums located in Canada, which is principal role is publicizing astronomy and popularizing and sort of showing what is going on, what professional astronomers are doing. The McLaughlin Planetarium in Toronto is the largest planetarium that we have in Canada. This is a photograph of it, and again we see we have a dome, but we're not looking at an observatory. We're looking at the dome, and beneath that dome is the Star Theater of the planetarium. The Star Theater is a place where we put on what we call shows, and we can do a variety of things when we have these shows. We can have programs for public, for school children. The McLaughlin Planetarium in Toronto has its dome is 23 meters in diameter, which makes it one of the 3 largest star theaters in North America, the larger ones being in Los Angeles and New York City.
So on the dome is projected the sky from a projector, so it's as if you're looking at the night sky?
As if you're looking at the night sky. We don't have a telescope under our dome. Instead, we have a large star projector. And the star projector projects images of the stars, sun, moon, planets onto the dome. The star projector weighs about 3 tons and is a very powerful way for presenting the night sky. We can show the sky a person might see tonight or night of their birthday, several thousand years into the future, several thousand years in the past. It's almost a time machine.
You can also go to any different part of the Earth if you want. You can see what the sky looks like from the South Pole without having to go there.
Exactly, we could do that. And it's a very powerful way for kind of looking at our sky and learning something about it, particularly when we've got conditions in southern Ontario where often we can't see the stars.
Right.
And we can come to the planetarium and actually see these objects and what is being done by professional astronomers.
What about other planetariums then in Canada?
There are 2 other planetariums in Toronto. The Ontario Science Centre has a small planetarium, and also Seneca College, their Finch campus, have a small planetarium. There are other major public planetariums in Vancouver, Calgary, Winnipeg, and Montreal. And we also have another public planetarium, Canada's oldest public planetarium, in the city of Edmonton. And currently there are plans to build a much larger planetarium in the city of Edmonton.
That's the Queen Elizabeth.
That'll be, well, the present telescope is the Queen Elizabeth II planetarium. I don't know if they're going to use the same name
Queen
for the new
Elizabeth
planetarium.
II or something.
That's it. It could be something like that.
A lot of studies show, and it's very obvious, that you watching out there are more interested in science these days. You're much more interested in astronomy. That could be due to the space program, due to the Voyager pictures from Saturn. And that I think, makes planetariums very good because it gives people like Ian a chance to explain things in a way that maybe what you read in the newspapers or see on TV doesn't really make things clear. I remember with the Saturn encounter, it made perfect sense to me, but someone who doesn't even know what Saturn is may find it difficult to to understand what's going on.
That's right. I think it's astronomy education is extremely important, and it's important to communicate between the professional astronomers what's going on in the sky that we're observing, and to the general public, so they know what is happening.
Well, a lot of astronomers are not professionals; they are amateurs, and astronomy is their hobby.
Well, amateur astronomy is an area where everyone can get into. You don't need to have an enormous telescope in order to do amateur astronomy. You don't need to have lots of money in order to do it. You can go ahead and use some kind of a telescope. This is, for example, an old cartoon, which shows a lot of people out with their telescopes looking at a comet going across the sky. Now, normal impression is amateur astronomy. You have to have a telescope. But actually, this is not really necessarily true. You can use just your eyes alone in order to learn something about the stars, the constellations, identify the planets, motions of the moon, the sun. You can use a pair of binoculars. A lot of people do astrophotography. And eventually, many amateurs go ahead and actually get a telescope so they can observe what is going on. Here we have an amateur who has a homemade telescope. He's located in front of the David Dunlop Observatory. And many amateurs eventually go ahead and get their own telescope.
Mm-hmm. This is in front of the DDO. A lot of members of the Toronto Centre of the Royal Astronomical Society, of which Ian is the president, build their own telescopes, and we also have parties where we get out with our telescopes and look at the sky and just get together and see what kind of things we have. As here we have a 12.5-inch reflector, which was built by a member of the Toronto Centre.
That's right. It's great. It's a fairly large amateur telescope, and it's being used for a star party, and it provides a excellent view of galaxies and star clusters and many very beautiful objects that are visible in amateur telescopes of the sky.
Is making a telescope a difficult thing to do?
Many astronomers, amateur astronomers, can buy telescopes. But a lot of amateurs also go ahead and build their telescopes. There's a lot of fun in actually building your own telescope, going and getting a mirror blank, grinding the mirror, assembling the telescope, and this means the telescope's not a black box. It's something that you can actually study, and you're familiar with how it operates, and you can use it to its maximum potential.
Here you see a young astronomer grinding his mirror, which is just a simple act of grinding two pieces of glass together, and the top one is hollowed out, and the bottom one is convex, and what he has in his hand is the mirror.
Depending upon an amateur's ability to kind of rummage around and a little bit of talent that they have, you can go ahead and build a telescope yourself. This is a photograph of a comet, and I might perhaps mention something about what amateur astronomers have been doing. There are some very well-known Canadian amateurs like Rolf Meyer, who is lives in Ottawa, and in the last 3 years he has discovered 3 comets. And when you discover a comet, the comet's named after you. And so in the last 3 years, we've had 3 Comet Meyers that have been visible in the sky.
Well, how many comets are discovered every year?
Oh, every year there are approximately about 10 comets that are discovered. Many of them are discovered by professional astronomers, but there are quite a few that are discovered by amateur astronomers.
What about if anyone out there is interested in the Toronto Centre? Maybe we could talk a bit about the RASC itself in these last few minutes.
Okay, well, the Toronto Centre is one of 19 clubs or centres of the Society across Canada. The Toronto Centre is a very large astronomical club. We have about 700 members, and there's quite a few activities. The McLaughlin Planetarium is the headquarters for the Toronto Centre. We have meetings, we have star parties, we have an observatory, we have a telescope makers group. We do public education types of programs, set telescopes up at libraries and parks, and do various programs like that. We have a newsletter, goes out to the membership, and a variety of publications which help to explain something about astronomy and encourage communication among other amateurs.
Well, the most interesting thing I think that we have done in the Toronto Centre lately is we've gone to see 2 total solar eclipses, one in Manitoba and one just last year in Kenya. And Astronomy Toronto will be doing a show on these eclipses in the near future, so maybe you'll be looking forward to seeing that.
Oh, that should be excellent. I think the eclipse expeditions were very exciting. I know as we both went on these, they found them very enjoyable.
That's right. Well, thanks very much for coming by today.
Thank you, Randy.
As president of the RASC, maybe we should mention that if you are interested in learning more about the RASC, you can just drop a line to the RASC, care of the McLaughlin Planetarium in Toronto. That's all from here. My name is Randy Attwood. Thanks a lot for watching Astronomy Toronto, and we'll be seeing you again soon in the near future.